Hello again, this is Mrs. Simons with section 7.5, solving two-step inequalities. Recently we've been solving one-step inequalities, performing only one operation on both sides of the inequality. Now we're going to look at needing to do two different steps to isolate that variable. So again, our goal is to get this variable by itself. We want to undo the operations that are currently happening to that variable. That variable is being multiplied by 2 and then subtracting by 3. And so what we're going to do is undo addition and subtraction first, undoing subtracting 3 with adding 3 on both sides. That eliminates that negative 3 by adding 3 so that we now have 2y is less than or equal to negative 2. Then to get this y by itself, we're going to undo that times 2 with dividing by 2. And since we are dividing each side by a positive 2, that inequality symbol is going to stay the same, and y is less than or equal to negative 1. Just like we learned in a previous lesson when we were graphing those possible answers, we're going to put that negative 1 in the center and go up a few and down a few just to show that we know numbers to the left get smaller, numbers to the right get larger. And then we're going to go and plot our closed circle over negative 1 because of this or equal to symbol, that part right there that looks like an equal sign. We know that this answer can include negative 1. It's also values that are less than that negative 1, which will go in this direction. You may recall that there is kind of a shortcut that if you're dealing with this inequality and the variable is listed first, as it is right here, with that y being listed first, then we can actually take that little arrow as the direction that our graph is going. And again, that only works if the variable is listed first. All right, let's take a look at the other example that I have over here. We have an x on the right side of my inequality we want isolated. It's currently being multiplied by negative or by positive 1/2, and then we are subtracting 6. We always undo addition and subtraction first, so I'm going to undo subtracting 6 with adding 6. Always double checking that what we're doing really does cancel out. So negative 6 and a positive 6 cancel out. We bring down on the right side a 1/2 x that remains. The inequality symbol stays the same, and negative 10 plus 6 more would be negative 4. Then in getting this x by itself, we could either divide by 1/2, or I think it's easier than dividing by a fraction is to multiply by its reciprocal. And so we are multiplying both sides by 2. The numerator and denominator here cancel out, giving us just an x. Since what we multiplied on both sides is a positive, that inequality symbol stays the same, and 2 times negative 4 is negative 8. Now I still do highly recommend that you rewrite that with the variable listed first. If you're going to do that, you just need to make sure that the statement is still true. So if the alligator was eating the negative 8, it still needs to eat the negative 8. Again, if we were to graph this inequality, negative 8 would be in the center of our number line, going bigger to the right and smaller to the left. Since it again has an or equal to, that's that second line underneath the inequality, we know that we're talking about values that could be negative 8 or values that are smaller. And so again, we find we have a closed circle and an arrow going to the left. And that is because when our variable is listed first, we have a less than or equal to. So our arrow is going to the left. Okay, let's take a look at some other examples. These are a little more challenging, and very soon you'll understand why. Again, we want this variable x by itself. We see it's currently being multiplied by negative 1/2 or 1/3, and we're adding 6. Always undoing addition and subtraction first. I'm going to undo adding 6 with subtracting 6 on both sides. That positive 6 and negative 6 cancel out. We bring down our negative 1/3 x. We bring down our inequality. And I still see quite a few errors with students combining these two. remember that that is a negative 9 minus 6. So if we keep change, we really are just adding those, and we are getting a negative 15. Again, still wanting to get this variable by itself. Instead of dividing by negative 1/3, I think it makes more sense to multiply by the reciprocal. So that reciprocal is still going to be negative, but we're going to be multiplying both sides by negative 3/1. At this point, I'm hoping that you recognize that this problem is a little bit different in the fact that we are multiplying both the right side and the left side by a negative. And that rule for inequalities, if you multiply or divide both sides of the inequality by a negative, that is going to reverse the symbol, the inequality symbol. So that greater than symbol is now a less than symbol. The 3's again cancel out. Actually, it's the negative 3's that cancel out. We're just left with x. And on the left side, we're going to have a positive 45. I always think inequalities make a little more sense with the variable listed first, so I would again flip-flop the x and 45, making sure that if the alligator was eating the x, that it's still eating the x. And if we needed a visual of what kind of numbers would make this inequality true, we know that we're dealing with 45, and we want to graph out, are the values larger than 45 solutions or smaller? And so as I look at my inequality, I know that it is not going to be equal to 45. The reason I know it's not equal to 45 is because there is no or equal to symbol. It's simply a greater than symbol. And so values that are greater than 45 on the number line are going to go to the right. So 45 is not a solution, but if we were to plug in any number bigger than 45, that of course would be being plugged in up here in the original problem, that would be true. Anything less than 45 when plugged in would not be true. All right, let's look at one more example. If I go to isolate this variable m, I'm going to undo addition and subtraction first, so I'll undo adding 4 with subtracting 4 on both sides. Now, even though you see what looks like two negatives on both sides, it's not multiplying or dividing. This negative 4 is a minus 4, and so subtracting 4 on both sides means that my inequality symbol stays the same. So this is still a less than or equal to. It's just that on the left side of that inequality, we now only have negative 2m, and on the right side, 34 minus 4 is 30. I continue to get this variable m by itself. That's now times negative 2, so I'm going to undo multiplying by negative 2 with dividing by negative 2. Now when we see those negatives on both sides, this is dividing by a negative 2 and dividing by a negative 2 on both sides. So that tells me that the inequality symbol is going to flip. So it's going to go from a less than or equal to symbol to a greater than or equal to symbol. These negative 2's cancel out, and we have m is greater than or equal to negative 15. On a number line, that means that we are dealing with negative 15. Values that are bigger than negative 15 are to the right and smaller are to the left. Because of this or equal to symbol, that means it can be 15. Since it can be 15, it will be a solid dot. So 15, if we were to plug it in up here at m, would work, but so will all the values that are greater than. And so values that are bigger than 15 would be to the right on my number line. Again, just a reminder that because my variable is listed first, if I were to go and draw an arrow using that inequality as the point, it is the same direction as my graph here. And again, that only works if the variable is listed first. All right, let's look at this last problem. You want to spend at most $10 for a taxi ride. Before you go anywhere, the taxi driver sets the meter at an initial charge of $2. The meter then adds $1.25 for every mile driven. If you plan on a $1 tip, what is the farthest you can go? Well, I guess we do have to assume that we're not needing to get back and that we're just trying to get somewhere. And so we know that we need our taxi ride. We need our taxi ride to be at most $10, which means it can equal exactly $10 or it needs to be less. So again, we've got at most is going to translate into this less than or equal to symbol. Now, my taxi ride I know includes the initial $2 plus we know it's $1.25 for every mile driven. So my variable x represents what they're asking us to find, which is what's the farthest we can go. So x represents number of miles. And so we're going to be multiplying $1.25 times x. For every mile that we travel, we owe $1.25. Now, included in that is an additional charge, or not charge, but piece of information that we want to leave a tip. So that means we need to add $1 to that so that all of that combined is less than or equal to 10. So this is a great multi-step inequality because we do have some like terms that do not have x's that we could combine. And maybe some of you would have done that at the very beginning and just said, hey, a $2 initial charge and a tip of $1, we know we have to have at least $3. Then the other remaining $7 are going to be telling us how far we can go at a rate of $1.25 per mile. And so if we were to isolate this x, we would undo addition and subtraction first. And it's not this addition sign that we're undoing. It's always the sign in front. So that is a plus 1.25x. So that makes that a positive term. The 3 is also a positive term because there's not a negative in front of it. So when we go to isolate it, we will be subtracting 3. And again, subtracting not because of this plus sign, but because it's a positive 3 that we want to take away. When we take away that 3, we're left with $1.25x is less than or equal to that 7. Then, to get x by itself, we would divide this 7 by $1.25. And I've gotten myself a little bit out of space here, but if I do just use a calculator, I should get that x is less than or equal to 5.6. And so as we think about how far can we plan on going, well, if we can go part of a mile, we could go no more than 5.6 miles. If we're just going whole number of miles or half numbers, we just know it has to be less than or equal to this 5.6 miles. All right, well, best of luck as you try solving two-step inequalities on your own.